Over the past few weeks, we have brainstormed, designed, and built a product for a human-centered user, and we came up with the RGBop Box. I'm Trenton Haynes, and I worked on the electronics and coding for the design.
I'm Trista Falk, and I worked on the on-chip design, prototyping, and 3D printing process.
And I'm Vaishnavi Vijay-Raghavan, and I worked on planning sketches, documentations, and also helped with 3D printing processes.
To begin, I wanted to go over our mission statement, which is to design and create tools that help those around us, no matter how many tries it takes. Our goal is to design a toy that helps kids with specifically cerebral palsy in the ages 2 to 5, since that's a critical developmental period. We wanted to target helping their fine motor skills, which tends to deal with eye-hand coordination. So that's how we came up with this idea of the RGBop Box.
So based off our research, we came up with 3 solutions that met our goal. One was a squeeze rattle, which was like a traditional rattle with a handle that had a squeezable material, and this was to help build grip strength. Another one was a memory keyboard, and this had multiple buttons and colorful LEDs, and the goal of this game was to improve hand-eye coordination and fine motor skills. And a third solution was a strongman game, and this was to build upper limb strength and gross motor skills. All 3 of our solutions focused on engagement, visual and auditory stimulation, and therapeutic benefits. We narrowed down our options to 2 designs, the memory board and a squeeze rattle. We took into consideration of the cost, ease of use, effectiveness, safety, and environmental impact. We placed the most importance on the effectiveness, which is how beneficial our design would be for our end user in terms of therapy. The memory board seemed to be the most well-rounded of the 2 options, as it covered cognitive development, fine motor skills, and hand-eye coordination. We also took into consideration of its safety and ease of use, and of the 2 options, we believe that the memory board was the most effective.
So here we have our initial circuit that we made in Tinkercad. The basic idea is that we have 3 buttons that have 3 different LEDs associated with them. And then we have an RGB LED over here. Now, when the circuit is run, this RGB LED will turn a random color that is one of these 3, and the user must press the correct button to increase their score. And then we have a buzzer here for when the score reaches a certain amount. So here's our flowchart for our code. Now, first we have our randomizer. This picks a random number 1 through 3, and each of these numbers are associated with a certain color. And if that color is picked, the RGB LED will turn that color. And then when we move on, we have our button checkers, and now these will check which button the user presses, and if the button they press matches the color number, then they get it right, of course. So their score increases and the light will shine, showing that it's right. But if they click the wrong button, their score will not increase and it will flash the correct answer. And then at the end, it checks if the score has reached a certain amount. And if that amount is reached, then all the LEDs turn on, the RGB LED turns off, and the buzzer plays a tune, and this entire program will loop itself and continue. So here's our full flow chart. As you can see, it kind of makes a circular pattern as a loop. There's the first section, second section, third section. So here's our in progress circuit. This is a very basic mock-up. And then here's our final circuit that is fully functional.
During our design process, we needed to figure out a way to connect our circuits to our physical design for the user. And so we came up with creating these conic structures so that we could connect the buttons to the buttons on our circuit board. And so in order to get that button feel, however, we decided to use plastic and rubber bands to create sort of suspension with these conic structures in order to give that button feel when pressed down on, so that they can spring back up and spring down. And then for our limitations in this design process, we realized that our speaker wasn't loud enough due to constraint with our materials. But it not being loud enough could be an issue if the user is possibly deaf, which tends to be a kind of an issue within this community sometimes. And then the buttons could be a bit more satisfying to press for sensory reasons. And then the brightness could also be, being able to control that could also be good if the user has issues with sight. And then lack of repeatability is also an issue because if it wants to be continuously usable, and also needs to be plugged in, which could limit portability.
So our initial design started off with 5 large opaque buttons and several LEDs scattered throughout our design. But then as time progressed, we decided to cut down to 3 large buttons and fewer LEDs to save power and resource. We were also considering adding straps or handles on the side that would be attached to wheelchairs, but due to material constraints, we weren't able to incorporate this in our final design. And also, as we were beginning to build our design, we realized that we would have to move our buttons around and our buzzer so that it would be able to fit on our circuit. And so when we were building our final design, we added some foam boards to hold our circuit in place and added rails to ensure that the interior of our design was stable. And so here is our final product, and we'll be moving on to our demonstration now.